Question 50. A physicist observes a stationary bare nucleus undergoes radioactive decay in a uniform magnetic field. Two traces were made by the product's paths as in the diagram shown. The diameter of the bigger circle to that of the smaller circle is 16:1. He ponders over the four statements made by his colleagues. Number 1, the nucleus underwent alpha decay. Number 2, the recoil nucleus path follows the smaller circle in the anti-clockwise direction. Number 3, the atomic number of the nucleus was originally 15. Number 4, the period of the recoil nucleus and the radioactive entity has the same period. Which of the above statements are true? First, what we can read from two circular traces is the magnitude of charge carried by the two particles after decay. This is by equating the force of circular motion to the magnetic force. We can show that the radius and the charge are inversely proportional to each other. We can make use of this relation to show that the nucleus after decay will have a charge 16 times larger than the charge of the radioactive particle. Since alpha decay appears in the first statement, we first try to figure out which kind of decay is most likely to happen in this situation. If the radioactive particle is alpha particle, the nucleus before decay will have 2 plus 16 times 2 protons, since alpha particle carries 2 protons and 2 neutrons. Knowing the original nucleus has 34 protons, we then go to check the profile of radioactive decays as a function of the number of proton and neutron. Clearly we can see that the number of protons in this case is not sufficient to allow alpha decay. So statement 1 is wrong. Next let us consider beta decay. Beta particle carries a negative charge with a magnitude of 1. Since beta decay will cause the original nucleus to gain one more proton, to obtain the initial proton number we must subtract the number of beta particles. In this case, only one radioactive particle presents. The initial proton number is then 16 minus 1, equal to 15. According to the profile on the left, this is possible to happen. This also means that statement 3 satisfies the given charge ratio. Next, we discuss the direction of the motion of the two particles after decay, given the magnetic field is pointing perpendicularly into the plane. Reminded that the bigger circle is for the radioactive particle while smaller circle for the nucleus. Since beta particle is negatively charged, according to right-hand grip rule, it will move in the bigger circle in clockwise direction. Conversely, the positively charged nucleus will move in the smaller circle in counterclockwise direction. Thus statement 2 is true for beta decay. Lastly, let us talk about the period. Recall that we can also express the force of circular motion as mr omega square. This omega is the so-called angular speed or angular frequency, and in principle we can define it to be 2 pi over the period, t. This allows us to relate the period of completing the circle to the radius of circle. They are shown to be proportional to each other. Thus, the periods of the two particles are different because it is radius dependent. Statement 4 is then wrong. Hence, the answer is E.